Mr. Minnick here, explaining to my AB Java students his demo program, ComparableDemo2. In this main method, in this client class called ComparableDemo2, we have 4 objects. 2 are high school students and 2 you see are elementary school students. Scroll down the example to see those classes in more detail. I included them all in the same file for convenience. But notice the interesting aspect of this is that student 1 and 2 are cloaked, as I call it, as comparable references. Deep down, as I like to say, they are high school student objects. They are instantiated and as high school student objects, and we are using a other constructor coming out of the high school student class to create them as objects. But we are purposely downgrading them, if you will, as comparables. And the same way with student 3 and 4. Okay, so what's that benefit us? Let's trace the rest of the code. Well, first I'd like to point out that this is illegal. It's a compiler error if you try to use the getName method for student 1. But you argue the high school student class does have a getName method. And it's public. So it should be legal. Oh, but it's not. Because we put the word comparable there instead of high school student, you now can't use your getName method. Don't ask me at this time why this is necessary, why this is desirable. Just trust me, there are many situations where you want to downgrade an object and keep it from calling certain methods that are public out in the real world of software development. But in this situation, just know for the sake of the AP exam that it would be illegal to call the getName method. The only method that you could use in this situation is any method that's found in the comparable interface. And since the comparable interface is documented as part of the API of Java, and it only has one method in it compared to, for the rest of this segment, we can only use the compare_to method for students 1 and 2 and 3 and 4. So here goes. In this if-else, it's perfectly legal to call compare_to. Before we get there, notice that you can actually use getName if you do the following thing. If student 1 is temporarily casted on this line of code here to the high school student that it really is deep down, and you do need this extra set of parentheses right here to enforce the order of operations, you can make use of the getName method. So Angie does print out as a result of this line of code because student 1's myName property instance variable is Angie. Okay, back to the main point. In this section, a previous demo program already taught you how the if-else can be used to use the compare_to method in a meaningful way. We're printing out here that Angie is greater than Bill, and that just works because of probably the GPA is being used to, sorry, that's the wrong output. Here's the correct output for the program, and we do see that, sorry, Angie is greater than Bill. I think GPA is used in the compare_to method. We'll soon see. Okay, and notice that toString is optional here. You don't need to type out .toString. You can simply say student1 concatenated with the phrase is less than. The toString method is automatically invoked behind the scenes. Okay, the real point of this demo program. Here we have a system out print statement, and we're calling a method that I just simply typed out and included in this client class. I made up the name of the method compareStudents. I put in 2 parameters. We are passing student 1 in, which matches up with student A. Student 2 matches the formal parameter student B. But notice, instead of putting high school student or elementary school student, I put comparable here. And that's perfectly legal. In fact, it makes this method flexible, and it can be used for either high school students or elementary students. Indeed, I do that here, proving that that's flexible in that way. And also, interestingly, the return type of this method compare students is not int, it's not double, it's not string, it's not boolean, and it's not void. It's comparable. So I didn't even put the word high school student there. I put comparable, which is perfectly legal. That makes this even more flexible. In fact, this method is so flexible, you could pass strings to it to compare two strings to each other, and it would still work, because the string class does implement the comparable interface, and so do hundreds, maybe even 1,000 other classes across the world. So this is a very, very flexible method that could be used in many programs. Okay, moving on then to analyze what happens inside our method compare students. Well, it simply has this if-else if that compares the two parameters and returns which object, well, a reference to the object, of which one is considered greater than the other. And it works. And by the way, if they're equal to each other, instead of putting return 0, which would not be allowed here because we're not returning an int, I'm returning student A. Well, if they're equal, it doesn't matter whether I return student A or student B. So student A is just perfectly fine. It's used there. So that's a neat little piece of code there to trace, elegant. And we are returning a whole student object, a reference to a whole student object. So up here, where the call statement is found, this simply simplifies to something like student 1, if student 1 is the greater object. And therefore, the toString method is automatically executed behind the scenes. You don't have to type out toString. But then you might say, well, why is toString allowed? Because toString is not a method found in the comparable interface. So just like we couldn't call getName, we should not be allowed to call the toString method. Well, we haven't studied it yet, but because of what's called inheritance, and there's something called the object class that's automatically inherited in all situations by all classes, you can actually call the toString method. It's not equivalent to getName, and it would be legal there. Okay, that's it. That's all I had to say about this demo program. You can trace the code. I recommend that you copy and paste it and throw it into a compiler like JGrasp or Eclipse to mess with it and learn from it. And good luck. If you have any questions, contact me. Oh, one more thing. What if student 4 were replaced here with student 2? Well, that would kind of cause a problem because you're comparing an elementary school student with a high school student. Let's see what happens. This is the kind of playing around that I encourage you to do. Test the limits of Java code. Let's see if it compiles. Oh, it compiles. Well, it compiles because we have the word comparable here. And it doesn't care if you're trying to compare apples and oranges. So it's not a compiler error to put student 2 in there and try to compare an elementary student with a high school student. Let's run the program. Oh, now we have a problem. It's a runtime exception where you're trying somewhere behind the scenes to cast or depend on the compiler to change a high school student into an elementary school student for purposes of comparison. Well, that's just plain illegal. Because first of all, elementary school students, they have work ethics and a name, whereas a high school student has a GPA and a name, and additionally a height. So you cannot compare apples to oranges. And unfortunately, that's a runtime error that you learn about when the program executes. It's not a compiler error, because according to the compiler that sweeps through this code and just checks things like data types, semicolons, missing curly braces, and else clauses matching up with ifs, it doesn't catch you on that. But at the moment of the comparison, behind the scenes, when it calls the compare to and comes down here and tries to do this cast, well, this object, the one that's, well, anyway, at some point it tries to do this cast and it can't. It can't compare, it can't convert an elementary student into a high school student or vice versa. Okay, let me know if you have any questions further than that.